Welcome to The Explainer. Today, we're going to pull back the curtain on a machine that millions of us use every single day, probably without even a second thought.
I mean, have you ever really stopped to think about what's going on right under your feet? It just looks like a moving staircase, right? But the engineering that makes it all work, well, it's actually fascinating.
So, let's do it. Let's peel back those metal and glass panels and take a peek inside. We're going to see what makes this everyday marvel really tick.
Okay, first things first. We're heading into the engine room, so to speak. We'll start with the two absolute key parts that give the escalator all its muscle and motion, the frame and the motor.
The entire machine is built inside this massive steel cage called a truss. Think of it like the chassis of a car, but way, way bigger. This thing is so strong, it can hold the weight of over 100 people at once. It's incredible.
And then, tucked away where you almost never see it, usually up at the top landing, is the powerhouse. It's a big, heavy-duty electric motor, and it's pretty much the heart of the whole operation.
So that motor spins, but a gearbox slows it way down to give us that smooth, steady speed. Then, some huge gears pull on a massive step chain. You can kind of picture it like a giant bicycle chain, just pulling that entire loop of stairs around and around nonstop.
Okay, but that's just what makes it go. The real magic trick, the part that's actually kind of mind-bending, is the steps themselves. How do they just appear out of a flat floor, turn into a perfect staircase, and then vanish again at the top?
Yeah, think about it. If they're all just connected to a single chain, you'd think they would just dangle there or kind of flop all over the place. So how do they stay so perfectly level?
Well, the solution is this absolutely brilliant invention called the dual track system. And honestly, this right here, this is the real secret sauce of the escalator.
And here's the big reveal. It turns out each step doesn't just have one set of wheels, it has two. You've got your upper wheels and your lower wheels, and crucially, they each run on their own separate track.
So check this out. At the bottom where you step on, those two tracks are really close together, which makes the step lie flat. But as you start to go up the incline, the tracks actually spread apart. This forces the back of the step down, turning it into that perfect stair shape. And then at the top, the tracks come back together, the step flattens out, and then it disappears underneath to make the trip all over again. So clever.
Of course, while all that's happening, you need something to hold onto for balance. That's where the handrail comes in. It looks like a totally separate thing, but it's actually a big rubber belt that's hooked up to the very same motor. That's how it moves at the exact same speed as the steps. It's perfectly synchronized. So with all this heavy machinery moving around, you have to wonder, what keeps it all safe? Well, as it turns out, there are a surprising number of features designed purely for our protection. Some you might not even realize are for safety at all.
For example, what about those little brushes on the sides? You've definitely seen them, but do you actually know what they're for?
And here's a hint. They're not there to clean your shoes. I know, it's a common misconception, but their real job is actually a pretty clever safety feature.
Those brushes, called skirt brushes, are there to gently nudge your feet and maybe your shoelaces or shopping bag away from that tiny gap between the steps and the side panel. They work together with other things, like those yellow lines that show you where it's safe to stand, and the comb plates at the end that mesh with the steps to stop anything from getting pulled in. It's all one big safety system.
So let's wrap all this up. The next time you hop on an escalator, you can see it's not just one single invention, but really a combination of 5 brilliant engineering principles all working in harmony. Let's run through them. First up, it's a continuous loop. It's a simple idea, really. This constantly moving loop of interlocking steps powered by a single motor is what allows for that constant, smooth flow of people.
Number 2, the truss is its skeleton. And really, this thing is the unsung hero. It's the massive steel frame that has to bear the immense weight of both the machinery and all of the passengers without so much as a bend.
Third, there's that secret sauce, the dual track system. This is the truly ingenious part. This is what transforms a flat conveyor belt into a climbing staircase and then back again. It's pure mechanical magic. Fourth, the handrails are synchronized. This is so important. By linking the handrail to the very same drive system as the steps, it guarantees you have a stable, reliable anchor for your balance for the entire ride. And fifth, safety is never an afterthought. From the big, obvious emergency stop buttons to those subtle little skirt brushes, every single part of the design is thinking about how to prevent accidents before they can even happen.
You know, when you consider how all of those different systems have to work together so seamlessly, all day, every day, it's really hard to disagree with that.
It's just a beautiful example of engineering that's so successful we barely even notice it's there. Which makes you wonder, if that much genius went into making a staircase move in a straight line, what kind of puzzle would it be to make one that goes around a corner?